let's see some constant that we have in Scipy model and make a couple of exercises just to finish. Okay, so physics constant, we import constants is the model that contains the constant, and we have the speed of light, we have magnetic constant like this, the electron charge, molar gas constant, the fine structure constant, Avogadro number, and we call in like this. Okay, so just with the name. Okay, so you need to call one of these constants. Just use this. We will see more specific for astronomy constant in AstroPy. So we can use that, like the mass of the sun, more details there. Okay. Any question of this? The constants? No, right? Okay, so let's make this couple of exercises. First, fit a suitable function to this, to lesson 5 course fit 2. And second, create a circular mask, I mean what is equal 0 set within the circle, of radius r and center r in arbitrary point with our arbitrary radius, and apply to this max to this figure, to this image, and look only the data outside the mask. These are the two exercises. So let's start with the first one, which will be more easy.
Sebastian, yeah. I mean, it looks something like a linear thing, but it's not.
I don't think it's linear.
Okay.
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 Okay. It is sigma xy. Okay, you have imported. Okay.
Yeah.
No, but instead of that, no. Okay. Are you sure you're plotting the x and not the? Show me the. Oh, here. Yes, you are right.
It's x and y.
Yeah. Yes. Okay.
So
true? No, it's not linear.
It's probably some power law. It's
power law. Yeah. Exponential load or something like that. Exponential with some degree of decay. Okay. Or you can use a trial polynomial.
Let's try.
Let's try.
I have a problem with import matplotlib. Yes.
Which one? Error with?
Try to make it.
Problem with?
Import this.
Okay, try. Because it's not. Yes, it's okay. Matplotlib SPF. No, maybe it's not installed Matplotlib. Okay, import Matplotlib. Wait. Lib.
Sí, sí.
Okay.
Okay. Oh, the same problem.
But you have Matplotlib here.
We have changed we installed again. I don't know if.
Okay. Now. Okay.
Okay, I try again.
Yes.
Okay.
Working?
Yeah.
slide abbiamo fatto le maschere.
Sì.
Non proprio.
Ma devi aspettare. Devi aspettare un po' con la corsia.
Are you going to move the first? No, but it's exponential.
Yeah.
Yeah. Yeah. Okay.
Questa sarà polinomio.
So polynomial seems that no.
No.
So try
I
inverse
did power
exponential.
law.
Yeah.
Il Paolo.
Power law.
No, it's not.
No, exponential. Yeah. Okay. Yeah.
Sì, ma l'esponenziale come lo facciamo a trovare la...
X. So define the function which is npx, or is the scale
okay.
npx and minus x,
Ok, quindi non è... Okay.
and the decay rate of the exponential.
I have no idea where to start with the mask.
Non P. M. Oh, sorry. MA from non P.
Pi.
Yeah. Masked array.
Yeah. Okay, because we did.
Is in NumPy? I think
Yeah.
the third lesson.
Yeah.
Okay.
Okay. My mistake. Python,
Sí.
but I have no idea how to generate the mask. I understand.
So the mask.
Mask
So-
with array.
Let's try first. Let's try to use
But
instead
that's
of
me.
mask.
I don't know the others. That's me.
Oh, sorry. Instead of using a mask for NumPy, just generate Boolean array with true and false. So first, okay, we have to use here the mesh grid. Remember mesh grid?
Yeah.
So let's create
Okay.
our x and y. Because-
Of the size of the other.
Yeah, because now we have to create an array of the same size of the image with true and false in those points that we want to mask. Okay? So the first thing is just to create the x and y. X and y could be columns and rows. Okay.
Okay.
And use mesh grid to create x and y of the same size. Okay? And then we have, because we want to mask all the points that are within a radius, just we want to make, know what is the, let's say that we want to mask everything except at the center of the image. So let's locate first the center, more or less. Let's take about 50 or 100 radius pixel. Okay, so we have to set up the condition for filtering, take only the pixels that are outside or inside the radius. It doesn't matter because we can negate that matrix, okay? So let's say that we want x, we have our x coordinates, our y coordinates, and the formula for the radius. We impose less than the radius to the square, okay? We know the formula of the radius, okay? So let's say, I'm going to show you only for example. Okay, so let's say that we have so we have something like x equals np arrange, okay, whatever here, the size of the x, okay? Okay, I'm going to increase this, okay? The same for y. So with mesh grid,
Well,
x, sorry, this is capital, if not, it's going to be removed, okay? X and y, we create x and y of the same side, okay, of the image. So now we apply our condition. Once it's created, we can say, okay, something like this. No, let's say x. So L will be our logical matrix. That should be, say, something like, we have to define also this one, of the same side of this one, which is the center, right? To the square plus y to the square r square. Okay? Something like that. So we have to define r also, which is the radius. Okay? This is our radius. This is a pixel and this is not a matrix, should be. So we will obtain a logical matrix with true and false that fulfill this condition. So remember, this must be, this is a location, it's a number, okay? The center x0, y0 should be, must be the center of the image. Let's say that we want to mask the center. This is the size of the radius. Also, this is the radius in pixel that we want to mask. And x and y are two matrices of the same size of the image, okay, that we have created with mesh grid. With x, the columns, and y, the row or the opposite. So that is the first step.
now we have the mask. L is
So now plot.
It's a logic mask.
It's a logical one. Now plot the image with masked. Remember how to mask with logical?
No,
You can multiply directly. You multiply the image by logical. Oh, remember that the image has 3 channels. So first thing is collapse everything, okay? So because not we will have n by n by 3, okay? And we have to collapse the image.
The one thing that always confuses me is the way that it's transposed everything.
Yeah, that's right. Yeah, that's but you can use the transport image. Let's put that T. So you should convert image or think about that Y. The rows are the X and the columns are the Y. Just you can always check with shape that the shape is exactly the same.
Yeah. So I generate this L, the logical image, and then I use the transpose that with the image.
Okay. So plot. That's the plot. Multiply the logical for the image.
I want to
okay.
show.
Show. There's no right. Here, let's clean that one. Probably I'm not doing something. Yeah. Okay. No. You haven't plotted.
Oh yeah. Okay.
There you go. So if you negate that,
Okay.
so you will take.
And
Okay. There you go.
I got lost.
Okay. Just think. First step. Okay.
Facciamo il primo esercizio.
Okay. So first, Anna, we need to. Have you read and collapsed the image?
Yes.
Okay.
because I
Is
got
that?
the-
That is the collapse now. So we want to create a logical matrix of the same size of that. Okay.
Okay.
You can do with in different ways.
Okay.
Let's because we want to fulfill. We want to set up a condition. Okay. First,
Yes.
the equation of 0 to the square
Okay.
is 0 to the square equal. That is the equation for a felt. Okay. So now, but this is we have a matrix. Okay. We have a matrix. So
Before
we have
you
a.
create a mask with the 0, for instance?
No, you don't.
No.
This is directly is going to create the matrix.
Okay.
So
Okay.
we need. So let's think about a matrix of the same side of X, of the same side of the image.
Okay.
This is the center of the image, okay? The capital letters
Mm-hmm.
are matrix of the same side of the image.
Okay.
Why? This is the center image, and this is some radius. Let's say R. R to the square,
now.
where R could be 100. Okay.
Okay.
So now we need a matrix of the same size of the image of our image. Okay.
Yes.
So
this is the shape, the
that is the
size.
shape. So let's create first X and P arrange. Arrange because because the
okay.
pixels are the columns and the row.
Yeah.
Arrange is a noun, okay? Of the shape of image, shape,
Yes.
shape. One. In this case, is one because it's inverted the image. Remember, and y the same, but this is should be zero. Okay. And now you convert because this has the side of this axis, and this is the side of this axis. We want to convert to a matrix of this side by this side with mesh grid. So we say x, y, which are those here, is equal to and p mesh grid.
Sorry, I didn't listen.
Okay,
before.
x, y. That's it. And now you use this here for the condition.
Okay.
Okay, that's perfect. Now the filter. Once you have the image, you have it's very easy to apply you have the mask. It's very easy to apply. You directly apply to inside or outside. You decide. But what to apply.
Do we need the conversion to float on the image?
Yeah, I think so. Yeah, it's better. It's not needed. It's not needed because we are not adding any noise.
Okay, so it's.
But it's not needed.
Okay, then
Sorry. Sento. Scusa. Così? Ah.
Mesh grid.
Mesh. Pardon. should be something like this. Okay.
Yeah.
So blur the outside part of that. For sure, we can, instead of our radius, we can do the ellipse equation and make the same. Okay. So the first thing is just create the masked image. Do we have that?
Okay. Once you have created the mask, you have to
So the
multiply.
mask, okay, plot the mask now. In show mask. PL in show mask. Okay. So it's not necessary to use masked array for node B. Directly multiply the logical mask. Multiply the logical mask for the for.
It does work.
And that's work.
Okay.
Because it will take out the pixels that are not true.
Okay. I can do that now.
Yeah. Just multiply.
Just multiply L times image.
That's right. Or negate L times image if you want to plot the opposite. The first thing is just to create the mask. When we have the mask,
No,
okay.
ok. Questo è il plot precedente.
Bene. What function did you fit?
Io ho messo una... Cazzo, questo no. Anche continuo per esponenziale di...
By B, okay. Okay, maybe time B. Prova, instead of divide, just remove square 2 and time B. I think this is a better thing. So the def, okay, that's one. Remove the square there, there, and times B. Okay, that one. Now enter again, and now school fit. That's one. Okay. And plot the. That's it's the same. Okay, no problem with that.
Okay,
Just
okay.
that's one. Okay, and plot. Okay. Much better.
Ok.
Much better. Okay. Good. Okay, that's the mask. So it seems that is working. You can plot the opposite.
So the curious thing is that if I do this, my mask is the central part, and then I do the blur. Yeah. But this
Oh, Blu-ray is the
wait.
La condizione
is everything
no,
because
no.
you have no multiply.
No, I did that.
Okay.
Perché meno 300? Ma che quello l'hai deciso tu?
No, because you are using because if you with this it's going to plot with
no.
blur everything. Doesn't take into account the mask.
No.
No.
Okay.
So just multiply. You don't need to use mask array.
Okay,
Just
so image times
L or negate L.
No, io non ho
Okay.
capito. Aspetta, poi bisogna fare questa cosa di...
Okay, good. So it's the negation of L.
yeah. And then I sum the two images to get the internal part. Not
You can sum, but be careful because the edge could be overlapping. It's better if you sum
pad.
multiply by the negation by the mask. So
Okay.
so now plot instead of this, plot this multiplied by the negation. So multiply burden by the mask again. So because of the edge, right?
Yeah. No, this is
Okay. See the edge that are blurred?
Yeah.
Just multiply now exactly the same by L, by the mask. What is the mask at the right? You have
L.
L. Okay. So do exactly the same by multiply by L.
Okay.
There, exactly there.
No, I can.
Okay, just right there.
Not to center the...
Yes, just locate.
That's what I mean.
Yeah, I don't know if it's L or the other side.
navigation.
Okay, because it's in...
Yeah,
it's in
okay,
vertical,
so-
is you have to
Yeah.
transform,
Yeah.
transpose. Good, over. Okay, so the mass. Let me see. Okay, no, I don't think that's... Oh, match grid, okay. Side, but no, because X 0, okay, yes, is the medium, perfect, and X and Y you have defined. Okay, it's not needed to, okay, this is, I think it's going to take one less, because if you give 0 to the last side, the last is not taking. So remove the 0, remove the 0. That's one. Ok, aspetta.
Ah no, aspetta. Sì, ho capito. Sì, diviso 2 qua.
The rest is seems to be okay. So now the condition, where did you have to set up the condition? The condition. Okay, no, but it's you need to say less than equal than the radius. Yeah.
Sì, però...
Oh, now it's Mars. That's it. Okay, you have it. So now,
So now I need to...
so increase the radius
small
as it would be.
center.
Okay, just you can see the radius of here. Just okay, so this you see the radius there. Okay, where is the center? Sorry, you can put 100 pixel, whatever.
Ok.
Come va?
E devo entrare nell'ottica. Bisogna creare una.
So read the function first. Sorry, the image first, and collapse the image, the Andromeda, just to the 3 channels, just one. Okay, with empty zoom. Axis equal to 1. How are you going? Okay, that's it. This is okay. Problem? No, x0 and e0 is the location of the center. Okay, so you can measure directly with the pointer.
Okay.
Mass cannot. The mass should be less than the radius to the square. Less or equal the radius to the square. But x0 and e0 is just the center. Okay.
No, I can apply the filter only to the external part.
Just multiply your image by the mask. That
Yes.
is already done. Okay.
Yes.
That's right. If you negate mass, then it will be different. So
Oh.
this is okay. So you apply the filter to image mask.
Mhm.
Okay, that's it.
Trees.
Okay. first thing, we read the image, okay? We have already done this, okay? Oh, no, I'm not in there, so. Okay, we're okay. Oh, what's in there? Yeah. We read.
Mask però non c'è una terza, come faccio a fare?
First thing, we read the image, okay? And we want to collapse this thing. Okay, because we have EMG shape has 3 channels. So we collapse everything. Now image has these 2 channels. Okay? Yeah, image show. This is our image with all the channels collapsed. So let's say that we want something that we see the coordinate here, around here. So let's center our mask around here. So we define our x0. Like this. That's the position. Let's say. Remember that this is flipped, but this is giving the right x and y, okay? So let's say 408, and for y, this one, okay? So this is the center of our mask, okay? Now,
may we use directly EMG dot shape and take from here the
yes, if the center is if the center of the galaxy is in the center of the image.
Okay.
Yeah,
okay.
I don't know if it's probably it's very close. Okay, so yes, but we can use that. So now we have to define x and y. That will be our pixel to create an image of the same side, okay? To search for which pixel are inside or outside of the radius. So let's say that we want a radius of 100 pixels, okay? That's it. So now we define x equal to a list between 0 and the side of this shape, okay? So with our image, okay, actually it's image. Yeah, because we call it, okay? So length x, 800. So this is our x, okay? 800. And y, remember, because it's invert the columns are x. This is because it's in image shape. Yeah. Shape. Okay. This is x and this is y because it's the image is inverted. Okay. The rows are x. The columns y. Okay. This is this thing, which are the rows. In the first index is always the rows, and the rows are y, and the columns, which is always the second, is the x in that image. So what we have done is just this, and list between 0 for the number of pixels, okay, and the same for y. Okay, so we have this, and we have this for x and y. Okay, pixel. Now we have to combine x and y to obtain two arrays of the same size with mesh grid. X with mesh grid, and now we know x shape and a shape. So it has combined all the combination of x and y to obtain this image, because we are going to use a mask in an image of this dimension. We need to that x and y has the same dimension that our image. Okay. Now, just as we are very close. Now let's create a logical one with the condition. So we say x, which has been already created. All the value, okay. All the values in x and all the values in y. Just is the pixel. Okay, x and y are the pixels. What is inside x and y are the pixels. The combination of x and y. Okay, so we make this L equal to this, and with the condition. It's very simple. So this is the equation of the circle. Say x0 has been defined. It's a number. This is a matrix. This is a number to the square that must be less or equal than our radius to the square. So this will give a matrix of true and false, like this. Okay? Really? We can plot. Now L shape is the same shape of the image. So it's true when this condition is fulfilled and fails in other way. Here in show L. I say this is our mask. Now here is true, but we want the opposite. We want to that this is true here, but we don't want to apply our filter in the sentence outside. So we can negate directly that one, and will be the opposite. Okay, that's it. So yellow is true here now. Silver negation. So yellow is true now. Okay. No, that's what before, but it's deprecated now.
Ah, okay.
So it's tilde. So it's very easy. Just to apply the mask to the image, just we will have to multiply. So if we say PL in show here directly our image by L is the center, and if we multiply by the integration of L, either side. Very simple, okay? And now we want to filter this one. Okay, I'm going to call, just to be sure, what is the center? Well, no. Center image of the image is our image multiplied by the mask, okay? And the outside of the mask, everything outside, I'm going to call as image, just to be sure which one we are using, okay? Let's show the center. That is in other words, this is the center, and let's show the Oscar. It's the same, but I have called a name. I have called a name to this and this, okay? Now we want to apply our filter to the outside, to this image. Only this thing, okay? So let's do in this way. Filter image. So we take Gaussian filter for any image. We give the image that we want to filter and the sigma. Let's say 3, 5, 4. Let's try 5. Okay. And now we plot that one in show. There we go. But not because in the center we have, remember that here in the border there are values with some number that has been mixed with the center, okay? If we want to plot strictly the thing that is filtered and not that thing in the border, we can multiply directly by the mask. Let's say that by L. No, the other one. So let's multiply by the negation of the mask. As it's more clean, okay? So let's show if we count. Let's combine both this filter with the unfiltered. So let's say final will be, okay, let's call, yes. So the final will be our filtered image multiplied by the mask, just to be the border more well defined, plus the center multiplied by the mask, also just to be more well defined. Probably it's not needed here because the center has been not. This is probably not needed because the center has been not plural. Okay. PL in show EMG. Fine. There we go. Okay? Questions? For sure, we can also define instead of a circle an ellipse with some inclination, with the proper inclination on minor and major axis, and mask more adequately the filter. Or, for example, let's mask only those high values in the image. For example, let's say that we want to. That's our image, okay? Okay, what is the standard deviation of this? That is the standard deviation, okay? Let's mask everything about 3 sigma. Okay, let's do it. And, okay, let's put none in those. Let's find more than 3 sigma, and in those pixels put none value. So doesn't show, will not show.
volte nella direzione standard. Questo è abbastanza semplice, anzi 3 volte, questa in realtà io l'ho fatta un sigma, 3 sigma, allora se io faccio così funziona, poi funziona, minchia sotto però, questo è 3 sigma, quello è un sigma, questo è 3 sigma. Un comando,
Così
questo qua.
Infatti, come si fa? Sto pensando a quello. Come si fa?
È l'immagine che tu però
c'era
una
una
di 3 volte nella direzione standard.
Che era non fai contornando qualcosa.
Devi mettere il nome. Quello è l'evidenza del tanto. Tu devi mettere il nome.
In che senso?
Tu l'evidenzia
Che erano
che
così.
sopra 3 sigma.
Ma questo è l'immagine.
Ma devi mettere il nome.
Come no?
Devi mettere come un alternante.
Questa è
C'è un... no.
come si fa?
Però io posso applicarla questa cosa.
Sì, quella è una maschera, però devi far diventare quei valori nano.
Che idea?
Io lo farei di andare.
Con maschera veramente. Forse con una scheda in data type o
Vedere il valore nano.
la maschera gliela posso dare in boolean data type fill value. Si può usare come fill value il done? si converte una stringa o un numero a un floating point, ma a me serve il contrario, So that's the image. Now we're wondering.
That's the image masked.
Yeah, that's the 3 sigma, right?
Okay. Yes.
But now we're thinking about how to do that with.
Okay. I'll call it. Yes. So actually, it's 0 when the pixel mask has the value 0 now. Okay.
Yeah.
Okay. So I think with him show you can say directly. Let me check. Yeah. Let me show.
Perché?
No, not with him show. So you have to operate with. Yeah. So first, because none is a float, you have to convert the image to float. Okay? Because if not, it's going to complain about that you are using float in an array that is made of integers. So first, convert the image to float. So the result should be something like that, okay? This is 3 sigma.
Yeah.
Okay?
Yes.
Okay.
Yes.
So now, you have to use, okay, I want to show. So what we can do now is, now we have our true and false Boolean.
Yeah.
So true, we want to convert true to none. Okay, so we can say, okay, in those places where the logical image is true, put none. Okay? Okay, that's right. The thing is that we can use NP where. That's very fast.
Okay.
NP where our logical equal true and give the index. Will we return the index? Okay? But careful with that. So NP where return not a logical matrix. Return the index where that's the sentence is fulfilled, the request is fulfilled. Okay? So now we can use those index with our matrix, masked matrix, and say, okay, here instead of 0, put none. Okay? Should be something like this. Okay. Okay. So like this, where that is our mask matrix equal true, and we this return this thing. That's and then okay, but what we want to that's okay, and then it's better. Okay, it's a tupla. Yeah, so this is because we want the first element of the tupla. Okay. This is because we put here 0. We want the first element of the tupla, which is the unique one. Okay. Okay. So this is the index where it says where the mask is true. Okay. And now we want to use this index to assign none values to the matrix. But be careful, because if this is an array of number, and we cannot use directly this array in our image, because our image has dimension 2, and this array has dimension 1. We want to convert this array to index that can be used in a 2 dimension. This is a NumPy, is a new one code module that is unravel, and we will use that one. It's called unravel index. So let's say that you have obtained the index with this condition for a 2D image, but the index R is not by an array of 2 by 2, okay? It's just a list of index, an array of number that must be rearranged to be a 2 by 2 to be able to use in an image of 2 by 2. Okay, this is done with unravel index. So we give the index that is and the shape that we want to reshape for those index, and the shape is the shape of our filtered image. And then we obtain new index that can be used to assign num values to our masked image. So we use this thing. Okay. This is a tuple, but now it's a 2 by 2.
What is an I? Sorry.
It's nice, the new one that's being obtained like this.
Oh, wait.
Okay? Let me check something here. Just a second, testing something. Okay. Yeah, so I think, okay, one thing. Okay, so, again, it's not needed to take the, it's only taking the tuple is enough, the full tuple that is given by this. Okay, so
L is the mask.
L is the mask. Okay, we are saying, okay, give me the index in L that are true. Okay, so NN are the index, and we have seen. Okay, oh, but this is a P shape. Okay. But okay, if we use, see, if now we use this index that we have created, okay, like this, in this directly with our filter image, okay, with the mask, with the image that has been masked, the result is not what we expect. Is not a 2 by 2 image, because it take this row, the first row, the second row, and put here the third, the fourth. This is because it's the side, so we cannot use directly the index obtained like in this way in the image with the image. What we need is just come with unravel to convert to 2 by 2, okay, which is done in this way. Okay? And now we can say this thing. We can use this new index that has been converted 2 by 2. We can say final is equal to, let's copy our filter image. Okay, and now final with the unravel index, we say empty none. Okay? That's it. That's complete now. And we can plot now. Show. Here we go. Now, here says 0, but is actually is none. We can say here that we have image final. We have some none. Okay.
Okay.
I get an error about cannot convert float none to integer. That's because I didn't do the float
Conversion.
transformation. Okay.
Yeah, because none is
No,
a
actually
float.
I did it, but then I
Okay, we
went
right.
yeah.
Move on.
No, io oggi devo...
Hai perso un po' di pezzi.
Ok. No,
Mariana?
no, me lo vedo dopo con calma.
Ok, bene, bene.
Siamo vicini all'una.
Okay, in order to resolve the other exercise, this one I'm putting in the classroom, so
Okay.
with all solutions. Okay. Okay, good. Any question? Very practice classes today.
Yeah.
So when is the next one? Mercoledì o
Venerdì?
venerdì?
Non mi ricordo onestamente, ci ho messo qui fuori.
No, venerdì.
Venerdì, okay. Venerdì will be working with AstroPy.
Venerdì
The
6
lesson
marzo.
is already there, so
Venerdì 6 marzo.
the lesson is in the classroom, so you can go out and we will practice with reading fixed image and making conversion and download fixed image from catalogs directly. So we will need internet connection, so you can do it. Okay. Okay. So try to install those things that we need from. Let's have a look. Check if everybody have the package that we need. Okay, lesson 5. Okay, so we are going to need no, that's AstroPy. That's is okay. Everybody has have AstroPy installed. Will you check that it's working?
Cosa?
AstroPy.
Ok.
Just write import AstroPy. Okay? And then another thing that we are going to use is datetime. Let's check if you have datetime. Import datetime.
L'abbiamo già usato.
Sì,
Abbiamo usato.
We have already used this.
And another thing is, okay, this is for AstroPy, no problem with this.
Okay.
No problem with this. AstroQuery. To make query to online catalogs. No?
No.
PIP. Installing the PIP. You have it?
neanche io ce l'ho.
No, but outside.
Outside.
So open a new. Okay, there. PIP3. 3 install AstroQuery. Spazio meno user.
Ah,
User. No, user. Come on?
name.
No, user.
Ah,
That user.
okay.
Okay, yeah. Go. So that's all that we will need there. I don't think that we will need anything else.
Sebastian, ti posso disturbare oggi pomeriggio?
Sì.
Chiudo lo streaming.
Yeah, that's for Astro Query. I don't think anything now. I don't think. AstroPy, this is fixed from AstroPy, no problem. Table, work coordinate system is for AstroPy, and that's it. Is installed? But has been installed.
Yes, successfully.
Installed. Okay, so try to import now.
PAP3.
You have it.
Ah, yes.